Problem number 5, we've got the integral here of a rational function, and so we know we're going to use partial fraction decomposition because this denominator will factor. You can factor an x out of that denominator. But before we do that, we can see this is not a proper fraction because of the x cubed in the top and the bottom, so I need to do long division. So let's start there. Let's divide x cubed plus x into x cubed 0x squared plus 2x plus 1. And we can see that the x cubed here is going to divide into this x cubed one time. Multiply that back out, you get x cubed plus x goes here. I'll subtract those. Get 0x cubed, 0x squared, 2x minus x will bring down an x and bring down a plus 1. But you're done because you're already in the constant column, so any other division you try to do here, you can have you'll have an x in the denominator still. So this integral can be written as the integral of 1 plus x plus 1 over x cubed plus x. Now, like I said, this denominator factors. Be sure you do it right and don't make this thing cancel somehow, but you can factor an x out. And that's it. You can't factor the x squared plus 1. It won't cancel with the x plus 1. But so I've got this denominator that I want to decompose. So I need to figure out what happens to x plus 1, x squared plus 1. That would come from partial fractions of a over x, and then we've got this x squared plus 1, which is a quadratic factor, and we know we need to have a bx plus c over the x squared plus 1 for that one. And then we go through the process. I'll clear out all these fractions, and I get this. On this first term, the x is canceled. On this second term, the x squared plus 1 is canceled. And so I just have that times x. And I could plug in x equals 0 and figure out the a. I'm just going to go ahead and do the equating coefficients. I think I'm going to need to do that for the b and the c anyway. And so we'll just see if the a doesn't drop out nicely in that process. Then I'll come back up here and plug in 0. Anyway, I get that b is multiplied by x squared and c is multiplied by x. So I've got each of these coefficients kind of listed out what they're multiplied by. And so I start equating them. The squared coefficient, there's 0x squareds on the left-hand side. There's an a plus b on the right-hand side. The x, there's a 1 on the left-hand side. There's a c on the right-hand side, so I already know what c is. And then my constant, there's a 1 on the left and a 1a on the right, and that's it. So my a equals 1, my c equals 1, but if a equals 1 and I add it to b and get 0, you can see that b is going to have to be minus 1. So my integral up here is going to become the integral 1 from the long division plus, we had 1, 1, and minus 1, so it actually is 1, minus 1, and 1 on my in here, so 1 for a, minus 1 for b, and 1. So it's 1 over x, 1x, minus 1 over x squared plus 1. And I can integrate these first two, but before I do that, let me split this other one up to get it ready to integrate. So this is going to be x over x squared plus 1 minus 1 over x squared plus 1. And this one I can do, it's in my list of integrals. This one I have to use a substitution, so let me get it set up. I get 2x dx here. So next step I'm going to go ahead and write down what these first ones are. This is going to just integrate and give me x. This is going to integrate and give me natural log of x. This next one I'm still integrating, but I did do a substitution, so I'm going to have the integral. I'm going to have a u in the denominator. You can see that the x dx that would be left here is going to get replaced by 1/2 du. And then minus, this one is, that's a 1, looks like an x. Now it looks like something completely different. Anyway, it's supposed to be a 1. 1 over x squared plus 1, we know that one is just going to give me an arctan, or tangent inverse of x. But I do need to finish that one. But that, again, is a natural log, so 1/2 natural log absolute value of u and putting the x squared plus 1 back in for u, I'm done. So that's log of absolute value of x, 1/2 natural log absolute value of x squared plus 1. The absolute value actually on this one's optional since that's already positive, but I'll just leave it, and plus a constant. Alright, on this next one, I'm asked to just set up the partial fraction decomposition for this, and this time it says I don't have to find any of the constants. I don't have to evaluate any of the integrals. I just want to rewrite the integral in terms of the potential partial fractions into which it might decompose. So that's just saying write out what this could have come from, this denominator. How could I have gotten this fraction with this denominator? Well, that means I could have, let's start with this one that's squared. That's a linear factor squared, so I could have something over its square, and I just keep going down, or something over it to the 1. I don't really have to put the parentheses in the 1. But the second one, it's cubed, so I have to account for all three of those. I could have the x squared plus 1 cubed, the x squared plus 1 squared, and I'm going to go down here, the x squared plus 1 to the 1 if you want to put it. You don't have to put it. Those could all be involved, but they may not be. I mean, I definitely have to have this term with the cube and this term with the square, but these other ones I may or may not have, but they have to be accounted for because these are potential partial fractions that could be involved. And then in the numerator of each of these, since this is a quadratic factor raised to a power, I have to do a quadratic, I have to account for that by getting a proper fraction by putting a cx and a d, and then this one an ex and an f, gx and an h. And that's all we're being asked to do. Just set the thing up. Don't try to find any of the coefficients. Don't do any of the work to find the coefficients. Just write down what could you end up having to integrate.